Good day, everyone. Welcome again to Quantitative Methods with Simulations and Modeling. And last time, we talked about the introductory part of regression. And in fact, we also discussed linear regression and multiple regression with examples. This time, we'll be talking about logistic regression. So what is logistic regression? Logistic regression analysis is used to examine the association of categorical or continuous independent variables or variable with one dichotomous dependent variable. Logistic regression is actually appropriate when, appropriate regression analysis to conduct when the dependent variable is dichotomous or binary, meaning to say we have a value of zeros and ones. Like all regression analysis, the logistic regression is a predictive analysis. It is used to basically describe and to explain the relationships between one dependent variable, binary variable, and one or more nominal, ordinal, interval, or ratio level independent variables. Looking into this formula here, where y is equals to p over 1 minus p, and 1 p over 1 minus p is our odds ratio. And therefore, with this, we took the logit, the logs of p, or the log of y, is equals to beta sub 0 plus beta times x. If there are so many independent variables, then we follow the same as the formula for multi linear regression. Types of logistic regressions. There are three types of logistic regression models, which are defined based on categorical response. One of which is the binary logistic regression, in which in this approach, the response or dependent variable is dichotomous in nature. Okay, example, it has only two possible outcomes, such as zeros and ones. Some popular examples of its use includes predicting if an email is a spam or not, spam or not spam, or if a tumor is malignant or not malignant. So within logistic regression, this is the most commonly used approach. And more generally, it is one of the most common classifier for binary classifications. Another one example is the multinomial logistic regression. In this type of logistic regression model, the dependent variable has three or more possible outcomes. However, these values have no specified order. So for example, the movie studios wants to predict what genre of films a moviegoer is likely to see to market films more effectively. The multinomial logistic regression can actually help the studio to determine the strength of influence, a person's age, gender, and dating status also may have on the type of film that they prefer. So now the studio can then orient an advertising company of a specific movie towards a group of people likely to go to see, to watch it. Okay. Another one is the ordinal logistic regression. So this type of logistic regression model is leveraged when the response variable has three or more possible outcome. But in this case, these values do have a defined order. Okay. So for example, of ordinal response includes grading scales from A to F or rating scales from 1 to 5. So in this case, we use ordinal logistic regression. Okay. Logistic regression within the machine learning, logistic regression belongs to the family of supervised machine learning models. It is also considered a discriminative model, which means that it attempts to distinguish between classes or categories. Unlike a generative algorithm such as naive Bayes, it cannot, as the name implies, generate information such as image of the class that is trying to predict. Example, a picture of a cat. You cannot do that in logistic regression. The logistic regression can also be prone to overfitting, particularly when there is a high number of predictor variables within the model. So what we're gonna have to do is to apply other algorithms to remove, okay, other algorithms, nothing to do when we design or when we test our model. Okay, regularization is typically used to penalize parameters a large coefficient when the model suffers from high dimensionality. So what you can do is regularizations here. So some uses of logistic regressions are the following. We have the fraud detection. Logistic regression models can help teams identify data anomalies, which are predictive of fraud. Okay, certain behaviors or characteristics may have a higher association with fraudulent activities, which is particularly helpful to banking and other financial institutions in protecting their clients. Another one is disease predictions. In medicine, this analytics approach can be used to predict the likelihood of disease or illness or illnesses for a given population. Now, healthcare organizations can actually set up preventive care for individuals that shows higher propensity for specific illnesses. Another example is the churn prediction, meaning its specific behaviors may be indicative of churn in different functions of an organization. Now, for example, human resource and management teams may want to know if there are high performers within the company who are at risk of leaving the organization. So this type of insight can actually prompt conversations to understand problem areas within the company, such as the culture or compensation. Alternatively, the sales organization may want to learn which of their clients are at risk of taking their business elsewhere. Now, this can prompt teams to set up a retention strategy to avoid lost revenues. Right? So that's all for today. And these are the references. I would like to acknowledge that some of the informations are taken from IBM websites, Statistics Solutions websites, and Science Direct websites. All right, so demonstration time. How do we perform logistic regression? All right, let me share with you my screen. Right, so let's clean up first so you will not see anything from here. All right, let's start from creating a new script here. Right, here you go. And then let's try to set our working directory. Okay, in this case, I will be putting my data or access my data in this directory. Okay, this one. Oops, cannot work. Oh, sorry. I missed one here. Variable. Okay, and then I'm going to access the data sets I'm going to work on. Still, we'll be using salaries at this time. We have here, as you can see before, these are in characters. These are A and B. Also for sex, these are male and female. So I just changed it to number coding so we can use logistic regression. And so you'll notice this is we'll be using a dichotomy type. Okay, dichotomy data to be predicted with the following predictors or independent variables. Okay, so let's import that. And I'm going and I'm going to pass it in a particular call this variable, right? So I'll put it in D. Okay. And then we will be accessing some libraries such as AOD, right? So if you do not have AOD library, what you're gonna have to do is to install it here. Click here and then write AOD. Okay, then click install. So after that, you can use it anyway. So this time I'm not going to install it because I have it already in my computer. All right, so let's run and then I'll be using another library, which is the ggplot2. All right, so let me check first the characteristics of our data sets. Right, so there you go. So we have here rank. Okay, so these are categorized as professor, assistant professor, and associate professor. For the discipline, these are ones and twos. These are A and B. Right, so sex is also dichotomous, male and female. 1 is male, 0 is female. So we are going to change this into a categorical by changing it to a factor. Okay, so we're gonna have to do is to change it. Okay, the rank, still variable rank. I'll be using factor function. Okay, and then we have the rank. Okay, you run. Let's try to copy this twice. Okay, so change this to this for discipline. Run. And then we have here sex. All right, so let's run. Let's try to again check what happened to our data. All right, so here we go. Our variable rank now has 3 factors or 3 levels: associate professor, assistant professor, and professor. So this is 1, 2, and 3 is professor. And for discipline factors, we have 2 levels, zeros and ones. Okay, 0, 1. No, and then we have also sex as 2 levels, as zeros and ones. Okay, let's start with let's try to check our data based on the levels. Okay, say for example, how many disciplines are there with this particular sex, right? How many males are there taking up this kind of discipline, A or B, right? So to do that, we're gonna have to use the X stubs, okay? And then the caret, the variable discipline, and the sex. Okay, so the data is coming from D. Let's check. All right, so there you go. In this case, for female, okay, for female, there are 18 that belongs to 0 or A, and 21 that belongs to discipline B, okay, or 1. For male rather, there are 163 male taking up this kind of discipline, 0, and 195 taking up this kind of discipline, right? So let's try to check other data. Let's say, for example, by rank, right? There you go. Okay, how many associate professor are there taking up this discipline, and for this discipline, 26, 38 respectively, right? So let's check about other data. Sex by rank. Oops. Okay. Oops. Sorry. There you go. So for female, there are 10 associate professor, 11 assistant professor, and 18 professors. For male, there are 54 associate professor, and then 56 assistant professors, and 248 professors. All right, so now we are ready to engage and write what do you call this? Um, our logistic regression model. All right, so these are just examples of how we describe descriptively our data. Right, so let's proceed. Assuming I'm going to use a variable log R for logistic regression. That's my model. And I will be, instead of using LM, I'll also be using GLM, which is general linear model for this purpose, for me to be able to generate a model for logistic regression. All right, so I will be using this or the discipline as my target variable or the dependent variable. And in this case, I'll be using all. Okay, caret, then space period. Period means all the variables in the data sets will be utilized, right? So then we have the data coming from D. Okay, and the family, since there are two values there, I'll be using binomial. Okay, so there you go. Let me check again. Okay, let's run. Okay, so let's try to look into the summary. Log R. Okay, so there you go. So you will notice that okay, only years in PhDs, years in service, and the salary who has a significant relationships with our dependent variable, which is discipline. The rest has nothing to do, such as sex, the ranks, specifically here, this one here, right? The ranks. So to improve our performance of the model, we will drop these variables because there's nothing, there's no associations in predicting the disciplines. Okay, so we're gonna have to change this. Okay, so I'll just copy it. Okay, so this time we're going to specify the variables. So we'll be using years in PhD. Okay, what else? We have here years in service as it's contribute to in predicting. And finally, the salary, right? Let's copy. There you go. Let's run. Okay, so it's much smaller now. There you go. So we have here our model. Okay, so to going back to the formula, the logic of P, okay, which is Y. Now the intercept is here. Okay, negative. Okay. Call this negative 1.103 raised to zeros. Okay. And then we have the first what do you call this predictor, which is years that PhD. So we have here plus the value of your beta is negative 1.074 raised to negative 1 times the years in PhD. And then plus the beta, which is 4.799 raised to negative 2 times years in service plus 2.492 raised to negative 5 times the salary. So that's our model for the logistic regression. Okay, so that will be all for today. Thank you very much for listening.